Welcome to Process Analytics. I am Dr. James Rowe from Roller College of Business at Rowan University. We are now on improve phase. We have considered define, measure, and analyze phase. After analyzing the collected process metrics using regression and hypothesis testing, one can move on to adopting the vital views and focus on them to improve. In a sense, define, measure, analyze phases are here for this improvement phase. In this session, we will examine three methods to improve processes. Module 4 looks at improve phase. There could be many methods to improve a process after quantitatively and qualitatively investigate a process. In this lecture, three things will be discussed: design of experiment, cycle time reduction, and theory of constraints. Let's first take a look at design of experiment. Why design of experiments? There are so many factors that come into the picture of process analytics. Instead of working with trivial many, it is critical for the business to come down to the vital few. Design of experiments is an effective way to determine what factors to screen out or in. DOE, design of experiment, is a methodology of varying a number of input vectors simultaneously in a carefully planned manner, such that their individual and combined effects on the output can be identified. Advantages of design of experiments are plenty. Many factors can be evaluated simultaneously, making the DOE process economical and less interruptive to normal operations. In-depth statistical knowledge is not always necessary to get a big benefit from standard planned experimentation. During an experiment, the important factors can be distinguished from the less important ones. Concentrated effort can then be directed at the important ones. If important factors are overlooked in an experiment, the result will indicate that they are overlooked. Results sometimes can be improved without additional cost, other than the cost associated with the trails. Cost savings can be therefore achieved. Other benefits of DOE is cause and effect relationship can be identified through DOE. Also, interaction effects can be discovered while conducting DOE. Here's a coffee bean example to understand the power of design of experiments. The left side is factor, and then the row are levels, low and high. There are two brands, Starbucks and Wawa. Spring water or tap water. Coffee amount is low or high, or 1 scoop or 2 scoop. The left column is called factor, and the right column indicates level. Response is an outcome of this experiment. In this case, coffee taste using design of experiment. The graph shows the main effect of Starbucks coffee from using spring water rather than tap water. It tastes much better when Starbucks coffee bean is used rather than Wawa brand, and also the water makes a difference. Next graph shows the impact of coffee amount. When changing the amount from 1 scoop to 2 scoop, the taste has become much better than before. When the slope of a line changes, we can say that there is an interaction effect. There is an interaction between coffee bean brand and the the amount of coffee. Through experiments, we can tell not only the main effects of a factor, but also interactions between two factors. This is the beauty of using design of experiments. Here are 7 steps of planning an experiment. First step, select a process. Second step, identify the output factor, Y. The third step, establish the input factors and levels. Fourth step, select a design. Fifth step, conduct the experiment. Sixth step, collect the data. Seventh, analyze the data and draw conclusions. And eighth, if desired, perform a confirmation run again so that you can verify the effect. The mini case that we will use is Chevy logo adhesion process. In upholstering the Chevy logo, there are at least 7 factors to probe. Adhesion area, type of glue, thickness of foam styrene, thickness of logo, amount of pressure, pressure application time, and primer applied. One would want to know which factor really counts for the gluing strength of the logo. For this reason, he or she can design experiments and conduct them and understand what is happening in the process. Doing so, the person can gain insights about business process improvement. So let us follow the steps together. Step 1, select a process. Chevy engineers finding the impact of factors for the glue strength, that is, the process that we chose to investigate. Second step, identify the output factor Y. We know it's a glue strength of the Chevy logo on a car. Step 3, establish the input factor X and level. The input factors, as we discussed, adhesion area, type of glue, thickness of foam, thickness of logo was those factors. We chose only 4 of them, and the level are two levels, high and low. Step 4, select a design. This is very important, and I encourage you to consult or refer to a professional design planning so that it will be done for you well. Adhesion area and type of glue, thickness of foam, and thickness of logo have to be evenly designed. And as you can see in this table, I gave um, uh, 3 plus for the first experiment. For the second one, 2 plus and negative, 2 negatives, and so forth. So doing so, you evenly distribute everything, and 4 pluses and 4 negatives, and that's all designed over here. Step 5, conduct the experiment. Make sure that the experimental designs are executed as planned. Step 6, collect the data. Collecting data can be tedious and difficult, but as long as you have the right data, record them in your data sheet, and this is going to be your data. And we find that the average is 11.075 after averaging the gluing strength. Step 7, analyze the data and draw conclusion. Um, Step 7 are for analysis of the data. Plus signs need to be replaced by the gluing strength of this one. 9.8 is the average that we had. And then you put them into plus signs and add negative in front of them when you designed it as a negative or none of that effect on there. So whenever you find the plus sign, you replace that with this average 8.9 there. And then if you had a negative or the absence of that factor, then you put negative over there. So in that way, you replace everything, then you will have the same data set that I have here. Then we need to sum them up by columns. So I sum them up here, negative 15 and negative zero point 0.6 and positive 1.8 and positive zero point 0.6. For example, negative 15 is the summed impact of input A, which is adhesion area. Similarly, 1.8 right here is the summed impact of input C, thickness of foam styrene. Now look at effect tabulation here. It divided the positive impact from negative impact. So we have positive together and negative together. In other words, you added the impact and Negative sign means the absence of the impact. To calculate these numbers, one has to add all the positive impact together and divide it by 4 to get an average value. So for example, 4.6 is the sum of these four numbers and divided by 4. That's 4.6. And 6.475 is a sum of these negative values and divided by 4. And for factor B, first two of them is positive, and then these two are positive, and add them up, divided by 4, it'll produce 5.5 and negative together, and that's going to be 5.575. And then you can visualize the number, which makes it easy for the reader to absorb the information. As for factor 8, adhesion area, when it is much more impactful and when the adhesive area is expanded larger than before. When it comes to thickness of foam thickness, making the foam thin is detrimental to the gluing strength. However, type of glue and thickness of logo did not make significant impact to the gluing strength. If you look at B and D, positive impact 5.5 and then absence of that is 5.575, so not much difference here, and similarly over here, not much difference. But A and C, they do have a lot of differences. So we see that A and C are more influential than the others. After this analysis, we are now in a position to make a conclusion. First, A has the strongest negative impact. It is better to stick with high level of adhesion area than to lower that. Second, C has a significant positive impact. Thickness of foam should be made thinner. Third, B and D are insignificant factors. Type of glue and thickness of logo do not really matter. Let's go over a few questions together. This question, I think, is very important for us to understand, and it's a challenging question. Consider the following data. 1 equals high, negative 1 is low. And what is the main effect of temperature in this experiment? So this is the main effect. Therefore, you have to add a high and low is negative low. So what you want to do is you want to find the temperature impact and 1, right? 1, it corresponds to 72, so 72 over here, and then over here is 72 and 68, and 1 is here 83, and then 1 is over there and 60, and that's a positive high impact. When temperature is high, what is the response? What response it is, right? So divided by 4, that gives you 7.75. And if you want to look at the low, the main effects of low temperature, then you can take a look at the negative 1 sign and then see the response variable as 60. So 60 plus and 54 plus 52 plus 45 and divided by 4, and that will give you 52.75. So the difference between high and low will be, in terms of main effects, 70.75 minus 52.75. So the difference is 18. So the answer, what is the main effect of temperature in this experiment, is that 18 is the answer, right? So 18 is the A here. So the answer is right here. Now let's think about DOE checklist. Define the objective of the experiment. So we have to carefully define it. The second thing is determine key independent and dependent variables carefully. And then select a standard design of experiment plan or develop one by consultation. Fourth, run experiments in random order and analyze results periodically. Randomization is very helpful because that does not, bias a result. So randomization prevents one from being biased. Fifth checklist is draw conclusions, and you want to verify by replicating experiments. Replication is key if you want to confirm the validity of the experiments. Let's solve these questions together. Which of the following is the best description of randomization? A means of ensuring parallel experimentation. B, a technique used to increase the validity of an experiment. C, the repetition of an observation or measurement. D, the relationship between two or more variables. The answer is B. It's to increase the validity of an experiment. Next question. When performing one experiment with 5 repetitions, what are the 6 experiments called? This is called replications. Another question here. A two-level five-factor experiment is being conducted to optimize the reliability of an electric control module. A half replicate of the standard full factory experiment is proposed. The number of treatment combinations will be. So notice that it's a half replicate, not full replicate. So first of all, we have to calculate the full replication or full factorial design. That's a level and to the power of fifth, right? We have two level and 5 factors. So to the power of fifth, and we get 16, and it's a half replicate, so you have to divide it by 2, so it's going to be 16. To end this DOE section, let us consider Albert Einstein's quote here. He said, "No amount of experimentation can prove me right. A single experiment can prove me wrong." I think this is a very significant statement from him. He, rightly stated that experimentation cannot prove anything right, right? However, a failure of experiment or an experiment can prove something very significant, and then it can deny or refute the other result. The other quote from him is, "Science can only ascertain what is, but not what should be, and outside of its domain value, judgments of all kinds remain necessary." So this tells us science may not be, it's only a tool. It cannot, give us right and wrong values there.